Okay, this is how this is going to work. I'm going to make videos of 5 questions each for the multiple choice. This is a very challenging test, this practice exam. Now don't get discouraged, we're going to get a lot of stuff wrong before we start getting things right. Hopefully we'll be able to get through 3 full practice exams before we take the real exam. Last year, going through this process, when the students did take the real exam, they came back and said it seemed to be a lot easier than the practice exams, and hopefully that happens again this year. Alright, so here we go with question number 1. So I'm going to assume that you tried the question, read the question, and struggled with the question before you watched this video. I think that would be a good idea. But here we go. Let's check it out. We have got an average of 8 ounces for these candy bars, standard deviation of 0.27 ounces. What is the probability that we get a candy bar that is 7.5 ounces or less? Okay, that's a z-score problem. Here we go. So it's kind of like this, right there. Here is our average. Here's 7.5. What's the probability that we're in this area of the graph? Classic z-score. So let's write that out. So let's see. What we observe, right, minus what we expect, and that's going to be over the standard deviation, which is 0.27. What is that z-score? So there it is. This 7.5 is 1.85 standard deviations below the average. We've normalized that curve. So now speaking of which, we go normal CDF to figure out what that is. And let's see, what would we do? We would do negative 1,000, negative 1,000 to negative 1.85 in normal CDF. And we figure out what that number is. And that number is 0.032. So that's like our p-value, right? Our p-value, okay, is 0.032. Devilish, because there is the answer right there, except they say, what is the probability that this happens twice? So what we got to do is, this is if it happens once, and then if we double it, that doesn't make sense because that would increase the probability. It would seem to make it, it would seem that it would have a smaller chance of happening twice in a row. Okay, since there's only a 3% chance that that would actually happen, so what we do is we multiply the probabilities. Whoops, 0.032. Okay, this times itself, and what does that give us? 0.001. Okay, which is choice A. There is the first question. All right, z-score with a twist, I guess you might say. Okay, let's go to the next question. So this is a least square regression line. And what they're going to do is they're just going to say, is there a relationship between how much experience these interviewers have based on how well they interview their subjects? Now, this is a confidence interval question. Let's see, 96% confidence interval. So we need a statistic plus or minus a critical value times the standard deviation. Maybe I should write that down. Okay, so what are we interested in? We're interested in the slope. Now, if you remember from that, let's see, we've got our constant is right here. Right here, this is going to be the slope of the line. So we're really looking at these coefficients right here. This stands for the standard error of the coefficient. Anyway, so it's kind of like y equals mx plus b. Here's our slope. That's our y-intercept. So we could cross off a couple of these choices because D and E are not going to work. The wrong slope. So now we got a better chance of getting the right answer just based on that. So let's take a look at some other stuff. Okay, so, well, you know what? I was look at these two are the same, right? Which means I think we're going to cross off A because we're going to get down to those two choices. But let me take a closer look. Oh yeah, the standard deviation of the slope, because that's what we're interested in, is 0.0205. So yes, it's going to be down to B or C. Now, unfortunately, we didn't get to chapter 12, and when we do this, it's a t interval, and the degrees of freedom are n minus 2. N minus 2. Okay, so let's figure out what that is. So if I use inverse t, and let's see, I want a 96% confidence interval, which means we put 0.98 in there. And then the degrees of freedom is the number of people, which was 10, minus 2. So I put degrees of freedom of 8, and it gives me 2.449. Letter C. Okay. Well, you may have not understood a lot of what I just said, but maybe you could cross these two off, and maybe you could have gotten these, right? And then you got a 50-50 shot at this thing. Okay, so let's go to the next question. Okay, this one, we're interested in the mean income of adults, and I think they're going to take a random sample by using driver's licenses. Now, the obvious problem is, what about the people that don't have driver's licenses? They're not even part of this group. So the information is not going to be real accurate. Now let's just be careful, because it says, which of the following statements is not correct? Okay? In fact, they capitalize not correct. So let's take a look at this. Okay, people had recently moved from another state, may not have DMV registry. Yep, that's true. So the sample would not be representative of adults, since teenagers would not be included. That's also true. The sample would be biased, since some people without licenses may be too poor to own a car. Yeah, that's all true. These are all problems with this situation. Letter D. The distribution of incomes in the sample would probably be skewed to the right. I'm not sure about that one, but let's take a look at letter E. Taking a bigger sample from the registry would solve any problems with this possible bias. Now that one is definitely not correct. If you take a bigger sample, you just get more of the wrong information. Okay, letter E. Unfortunately, they made us read all of those responses before we get to the right answer. God, these people. Okay, let's see. We're working with 98% confidence. So let's just do a quick review. Remember that, and maybe you already know this, but 98% confidence, right? We're looking at both sides. So we would go inverse norm. Where does that put us at? Well, there's 1% on either side. So don't forget, we go 0.99 in our inverse norm to get that critical value. Okay, let's do that. Okay, so let's see. Remember when we did problems like this? So we're trying to get within $500, right? We've got our critical value, which is 2.32, and we need the new standard deviation. So we would take the old standard deviation, which is, let's see, 2650 divided by the square root of how many we have. Well, that's what we're trying to figure out. So that's the whole question. Solve for n. If you remember, I think you remember doing these. Okay, so if we do that, let's see, we divide both sides by 2.32 to start with. Then we multiply both sides by the square root of n, which is right there. Now we divide both sides by 215.51. And then the last step, to get rid of that square root, we square both sides. And we end up with n is equal to 151.2, but there's probably a rounding error in there, which gives me letter D. There's that answer. Okay, like I said, this may ring a bell. Okay, well, expected value. The first group has 50% red and 50% green. So if you took a sample of 50 candies and half of them are red, how many would you expect to get red from that sample of 50? Well, half of them, 25. Now in the other sample, only 30% were red. Well, if you take 50 out of that, how many would you expect to be red? Well, 30% of 50 is 15. Now, add those together, and from the two samples, you should expect to have 40 red wrappers. Okay, well, you know what? That really helps us because we can now cross off these two choices. So now we just got to grapple with A, B, and C. Let's see what we got to do with that. So for expected value, how do we figure out the standard deviation? Well, for instance, let's take the 50-50 option, right? So the standard deviation of red would be the square root of how many in our sample, and it's the probability and 1 minus the probability, right? Okay, P and 1 minus P. Same thing with the other situation. So that would be another 50, right? But in that case, only 30% were red, and then multiply that by like that. And we would add those two together. So to summarize, you would have something like this. So for your expected value, it's 0.5 times 0.5 plus your other situation, another sample of 50, 0.3, whoops, times 0.7. And that would give you your standard deviation. And that is 4.796, choice B. Okay. Don't feel bad if you were just like, whoa, I got like none of those right. We are going to start getting these things right because we're going to start seeing these things over and over again. Okay? We're going to see questions like this. I'm going to say, oh, I remember. That's how you do that standard deviation. Okay? So don't get discouraged. And I'll make my next video maybe tonight. Okay, bye.